Let us look at past question and to end the discussion on distance bearing problems. Those who are doing EMAS, time could not permit me to do a tutorials for you before you leave. But within the vacation, maybe next week, I'll try as much as possible to do a video tutorials on trigonometry and upload it on YouTube, and I'll send the link to your parents. Those who can afford data, you can watch them online, download them and watch them online if you can afford the data. But if you can't afford, the CDs will be made available to you, of course, at no cost. It's part of the extra classes fee that you pay when you come back and that's them. So let's look at this one to end our tutorials on bearing. A ship leaves port P and sails on a bearing of north 45 degrees east to Port Q, 15 kilometers away. It then sails on a bearing of south 45 degrees east to Port R, also 20 kilometers away. Requirement: you have to represent the information in the diagram. Then calculate correctly the nearest whole number, the distance from P to R, and the bearing of P from R. This is compass bearing. It came last 2 years in OBDEC. I want you to pause the video, do the sketch, and compare your solution to what we shall be doing. Let's look at the solution. Let's assume this is the starting position P, left port P. This is my P. This is my P. Remember, you must always use capital letters. Then he sails north 45 degrees east. It implies at the North Pole turn 45 degrees towards the east. Then he moved 15 kilometers away. 15 kilometers. Let me end the 15 kilometers here. Remember, after you draw this line, all other lines will be subjected to this one. Then I close that position with another cardinal point. Good. And that position is called Q. Q. Capital letter Q. Then at Q, it then sail at the bearing of south 45 degrees east. It implies at the South Pole turn 45 degrees towards the east, then move 20 kilometers away. You can see this should be longer than this. Then this creates another position. This position will be my R, final position, my R. Capital letter. Then I enclose my triangle. Good. Then I indicate the angles. It's very much important. The 45 degrees east. Also here. -45 east. -45 east. Then south 45 degrees east. This position 2 is 45 degrees. So let's write a 45 degrees there. It's very important. In distance bearing problems, if you fail to write these things, you'll be penalized. Then the distance here is 15 kilometers. Let's indicate that one too. 15 kilometers, 15 kilometers away. Kilometers. And the distance here is 20 kilometers. 20 kilometers. km. That is a complete diagram. If you don't indicate these things, your diagram is incomplete. You lose marks. You lose marks. So let's push this one as up to the top so that we can get space for the calculations. The first question says we should calculate a distance from P to R. P to R. So let's analyze the diagram first and see whether we'll get a right angle triangle. A right angle triangle. The angle here is 45 degrees. It alternates with this angle here. So definitely this angle will also be 45 degrees. Alternating angles are equal. Oh la la. Then it means the full angle here will be 90 degrees. 45 plus 45 is 90 degrees. 45 plus 45. This angle will be 90 degrees, making this one our hypotenuse. In that instant, we can say that with regards to our II, the hypotenuse square, which is PR square, is equal to 15 square plus 20 square. I hope you can solve for the PR. I'm waiting for you to solve for the PR. Solve for the PR. You can pause the video and solve for the PR. The PR is equal to 25 kilometers. PR is equal to 25 kilometers. So the distance PR has been calculated. What is left is the bearing of P from R. P from R implies we are going to calculate the angular turn at R. Come in. The angular turn at R from this to this point. Remember, this is not a 3-digit bearing, so we're not going to calculate the angle from this direction up to the line. If you calculate the angle from this turn up to the line, it's not wrong, but you must convert your final answer to a compass bearing. That is something. When the question is given in a compass bearing, your answers and everything should be left in compass bearing. If it's a 3-digit bearing, your answers and everything should be left in the 3-digit bearing. So this is a compass bearing, so we need to calculate the angle at R. So we'll calculate for this angle here, the angle at this point, the angle at this point. You remember, if you calculate the angle this way, that will be a 3-digit bearing. That will not be wrong. It's another approach, but after you calculate the 3-digit bearing, you must convert it to compass bearing. But why not straightforward calculate the value of this angle? Good. Now the turn from here to this line is in 2 parts, this angle and this angle. The value of this angle, the first portion, is known, and that is the 45 degrees here. They alternate, so we only need to calculate for this one using the triangle. So let me indicate the 45 degrees here. That one we know it because of the alternating angles, it alternating counterparts. So let's go and calculate, look for how to calculate for the value of this angle. I will name the angle here angle T, angle T, angle T. Good. In that instant, we are going to apply any of the basic trigonometry ratio, any, because all the sides are known. We know the hypotenuse, we know the opposite, and we know the adjacent. We can apply any of the trig ratios, and I'll go to my favorite ratio, tan. Tan. So the second question, we are going to use tan. I hope you know the formula for tan already, so there's no need for me to write the formula for you. The formula is tan theta is equal to opposite over adjacent. This is our opposite and this is our adjacent. So this will be equal to 15 over 20. 15 over 20. 15 over 20. We will make t the subject. We'll make t the subject. So theta will cross the equal sign. And when theta cross the equal sign, become tan will cross the equal sign, and when it crosses the equal sign, it becomes tan inverse. Tan inverse. Tan inverse. So we are going to find tan inverse of our fraction. Tan inverse of our fraction. So you press on your calculator. This time around you have to press shift first, because we are looking for tan inverse. Tan inverse of 15 over 20. Tan inverse of 15 over 20. Tan inverse. What did you get when you press on your calculator? Tan inverse of 15 over 20. I'm waiting for you. Tan inverse of 15 over 20 is T. Our T will be equal to the value of tan inverse of 15 over 20, and that is 36.869. So we'll make it 87 degrees. Good. So if we want to look at the bearing, we know we have to add the 45 to it. The whole angle here. So we'll add 45 to it, but this one should be rounded to the nearest whole number. So our T degrees will be equal to 37 degrees. 37 degrees. Nearest whole number. Henceforth, the bearing of P from R is 45 degrees from R. Now to find the bearing of P from R, we add 45 degrees plus 37 degrees, and that will give us 77 degrees. 77 degrees. 77 degrees. Oh, 82. That will be 82, sorry. 82 degrees. 82 degrees. So in terms of compass bearing, that will be north. 82 degrees north, 82 degrees west in terms of compass bearing. Henceforth, the bearing of P from is north. Let me put this one should come here. It's north, 82 degrees west, and that's how I came about the 82. Henceforth, the bearing of P from R is north 82 degrees west. The 82 was obtained from adding the 45 degrees and then a 37. So that is the solution to the NOVDEC 2015 question on bearing. I hope you have understood the lesson. I will upload these lessons on YouTube in case you happen to have a problem with your CD. You can get a full tutorials on YouTube. All the best.